Welcome everyone. Thank you to vBrownBag for having us here for this particular tech talk. We're really excited about what we're going to be doing here today. My name's John Arrasjid. I'm VCDX #1. I work at VirtuStream, but I've worked at EMC's Office of the CTO and VMware for many years. This is my co-speaker.
And I'm Chris Gully. I work for the VMware Office CTO, group called Dell Technology Solutions, and we really are focused on innovation across the entire portfolio. Yep. So John and I took an opportunity to kind of talk about the things we're doing, and hopefully you guys have lots of good questions, and we'll go from there.
Yep. So first off, I have to give a disclaimer. We're not going to be presenting a roadmap. We're going to be talking about some things that are based on what is available today, but also what is to come in our vision. Where do we see things going for Internet of Things? It includes the devices, it includes the gateways, it includes AI and things like that. We'll get into those details. But again, any questions on specific roadmap details or schedules, we're not going to cover that because that's not what we're here for. We want to cover some specific things that we're working on and where we think you should be looking going forward. This is our agenda. We're going to talk about some use cases and one particular example tied to one of the POCs that we're doing with one of the companies that we've been partnered with, Toshiba, and they're doing AI as a service. We're doing platform for AI as a service as one of our research topic areas, and Chris and I are working together on expanding that so it's not just the AI, it's IoT. We're looking at the IoT challenges. We're looking at how AI fits into the picture, some of the design and operational patterns, and then how do we see Dell Technologies now working as a family as well as other partners working together in that ecosystem to deliver success. This is a part one. The deep dive is a part two, which will either be at VMworld Europe, but we've also been talking about doing a full vBrownBag with probably it's more than an hour on kind of the details. So we're going to give you a quick overview of this with some of the details and some of the vision for the future. Chris?
So, IoT landscape is pretty diverse, and we know it's evolving, and this slide really is just to show the dynamic elements that come into play as you go. They all have different types of connectivity. There's lots of connection points for information that come out of that, and we're looking at how do we extend compute further out to the edge so the customers have more capabilities closer to the data. They can do more real-time analysis as the ecosystem starts to evolve. IoT tends to be growing. I forgot the numbers, but they're large as we expand the capabilities. And obviously security is being critical to that. The analysis of data is critical, analytics, in the decoupling of points and things like that are growing and changing. GPUs are coming into play, acceleration, all that stuff is happening. We're looking at solutions that enable the customer to evolve in that ecosystem without having to learn it from scratch. And that's what we'll go into more.
Cool. So I'm not going to go into the details here, but I wanted to show you some of the things that we look at from IoT, edge computing, the devices that are out there. We're looking at different verticals. There's a focus that my group has had on a POC with Toshiba that's specifically around transportation. In the city of Tokyo, they're getting ready for the Olympics in 2020. They're working with the taxi companies. They don't have Uber and Lyft like here in the US, or it's not the same type of approach. They're focused on the taxis in support of a lot of different aspects. They have data coming from IoT devices, and they're doing AI, deep learning, and so on to make recommendations on route pathing and making sure that they meet the SLAs that are in there. Our focus specifically, though, is talking about, or more than specifically on AI, it's the bigger picture of IoT and how AI fits into that. So the use case for transportation is based on the POC that we've done. We have what we call a vehicular cloud. This is one of the industry terms that they have in the transportation industry, where you have different vehicles, different types of transportation systems. And the way that we look at things for our autonomous cars is somewhat similar to what we're trying to do here. What we're trying to do is look at the requests that are coming in for pickup and drop-off times and locations. In Japan, they will have up to 8 passengers, and so they have to make sure that if a new passenger is going to be picked up, they don't break any SLAs for any one of those maximum of eight passengers. Now, what we see going forward is edge gateways to collect data from these devices, do some initial analytics so that when you send, I'll call it scrubbed or sanitized data to a cloud somewhere for doing further analytics, that you can still follow geographic regional boundaries so that you can follow regulatory compliance. So do the more computing at the edge And this is something we'll talk about further with VMware Pulse IoT and several other technologies as well. Then we have a data and analytics cloud. This is where we believe there's a cloud of clouds, and you're seeing a bunch of bubbles, and this truly is a cloud of cloud. There may be one big cloud that is a system of these smaller clouds that have specialized purposes. One of these areas is for data storage. So we can have data storage related to the devices, status, and updates related to the sensors and the actuators. But we also have additional data that could be coming from the government, weather services. If you know about events, if you know that there's going to be an Olympics in your city, that's a major event. And if you look at the past history, if you don't manage transportation, it causes a lot of challenges, bottlenecks, traffic jams, and people missing, getting to go to some of those events. But we're factoring in weather, traffic, and thinking about it from a smart city perspective. Transportation is one aspect, but there's many more aspects that we can include as well. There's the analytics and AI. This is things like deep learning or inference engines that are created. So once you've done the deep learning, you can make recommendations based on new data. And finally, a user interface where if I have a device, I can request a taxi service, and based on the analytics, the inference engine, it can make a recommendation on which is the best fit for a taxi. Just because a taxi is here, and somebody in the front row here might be, the customer, it doesn't mean that I can actually pick you up and still meet my SLAs, and that's part of the intelligence in there.
And real quick, also, culturally, they have aging population that's outside,
Yes.
and so providing these services allows them to get the service needed to those folks. And to John's point, it's bringing all the data together. It's not having them siloed, it's being able to use all of that richness to then drive solutions that help solve problems for them moving forward. And again, meet SLAs that are very critical.
And this is just one use case. When we get into the deep dive in one of the following sessions, not at this conference, but later, we want to go into more examples around security, healthcare, and other areas to give you more examples. This is just one example related to the proof of concept that I'm working on, but there are many other ones that we have other team members working on as well. So we're going to split this up. I'm going to cover the first half, but we're not going to spend too much time. The deep dive will go into a lot more depth and more examples. But here are the top 8 that we believe are the ones from what we've learned and what we've seen from our customers and from our experience. Looking at integration in the cloud. How do we look at this? We look at it all the way from your core data center, maybe at your on-premise, and maybe our cloud or some other cloud, all the way to those edge devices. How do we make sure that we have that full integration, we have consistency, we have security? We need the IoT management from the edge to the cloud. We need to think about regulatory compliance, geographic boundaries, privacy protection, all these different things that come into play that force certain decisions to be made around the data and where the workloads are and where you get the access. And one important aspect of this is, with regulatory compliance, we see moving the workload closer to the data is the better fit for regulatory compliance than trying to move the data elsewhere. So if you look at GDPR or you look at individual country or regulatory compliances, you may have a boundary where you can't move the data out of there. No matter what you want to do, you can't move it. And in some cases, even if it's scrubbed, there may be restrictions on doing that. So we're trying to think more about that edge IoT.
Or even the costs too can play a role. Moving the data can be very costly.
So another area is on security and secure ledger. There's many transactions that are happening between the edge devices, the cloud, and all the intermediate areas. We do believe that with some of the new technologies out there, there's a particular VMware technology around blockchain for secure ledger that does, in some of the testing that they've already presented on, 60,000 transactions for secure ledger in the space of a second, versus maybe a dozen or so per second when you use traditional blockchain. And that, the VMware technology is with debugging turned on. So the expectation is going to be significantly higher. There will be sessions here at the conference I recommend going to see, in particular if you know Mike DiPetrillo, or if you don't know him, I definitely recommend going and seeing him if you are looking at that area.
And IoT skill sets being another one. As this ecosystem evolves, it's like software soup. You get all these things done, you have buzzwords, containers, AI, all these things are happening, but the skill set of the sysadmin, the OT, the IT person are being up-leveled, right? So they're having to learn new skill sets. It's a good thing, it's a challenge, I think. It's a paradigm shift to some extent, But I've seen that we're trying to create solutions that provide software that help bridge the gap between those, right? It's not just throwing it at them and saying, go figure it out. It's, hey, we've been thoughtful about it, and we're trying to give you the tools and the things necessary to go be successful. The bandwidth and latency obviously is critical, and I just mentioned, moving the data is important. Move the right data, don't move all the data. Moving all the data becomes costly. How do you normalize the information? How do you make sense out of it? And again, so as you move further out to the edge, latency becomes a real thing to deal with, right? And so you have to figure out, how do I optimize that for what I'm doing and know the sort of the bounds of that latency and bandwidth and leverage them to my advantage. And that's a challenge, I think, as 5G comes online. We'll have some new opportunities to realize more bandwidth, and the technologies will evolve with some of that technology coming. Data modeling, storage, and flow. As we put those all in one piece, but they're very critical. The data structure, it's easy to actually generate the information, but it's once you've got the data, what do you do with it? How do you get it somewhere? How do you normalize the data so you could use it in multiple potential clouds or on-premises data centers? So you have to make those decisions early and follow those as a sort of a foundational component for your IoT mantra, if you will, as you move forward. And then requirements of cloud. So that's sort of the overarching thing John and I are talking about, is that you're going to always have multiple clouds out there, whether it be your private cloud or your public cloud. The key is, how do you leverage all of them to work for you and not pin yourself into one technology that when you need to pivot, you're not unable to, right? So it's standardizing across things, leveraging the ability to use VirtuStream for mission critical applications, but then using other potential cloud providers for either their regional expansiveness or the collaboration because you have more people working in that ecosystem, or your data center itself because you've got the governance and security required to do that, but they all have to work together. They can't work independently.
And think of it this way, one master cloud for the analytics related to all of this, all these different components, and then the individual, maybe we call them subcomponents or the elements of this bigger cloud that focus on things like the storage cloud or an enterprise cloud on CPU or a GPU cloud for the accelerated requirements of AI workloads. Now, IoT, AI, we look at the data flow for Internet of Things. We start with looking at some of the training data. We get this information from devices. We might have reference information, and that's used to go to the next step where we do deep learning. We create what's called an inference engine, and that inference engine is where we actually have the ability to make a prediction. New data comes in, and we can say, based on past experience and our algorithms, here is a recommendation for the driver and a number of other elements in that system for the taxi service, if I go back to the POC. We have that model and classifier that does the actual inference. Typically, the deep learning is done at night. The inference is during the daytime. But as things advance with the accelerator technologies out there, we're going to see more and more analytics pushed to the edge and potentially even on devices. I don't know when they'll have it on the watches, but there's already been things that have been presented by NVIDIA and other companies about pushing analytics to your laptops, to your PDAs, your iPads, or your Android devices. So, and then there's the prediction when you actually have to make a decision. How does that happen? New information, a new request comes in, find the best way to respond to that and meet all the requirements around that. And if you run into a failure at any point, take that failure to additionally learn more, retrain, refine your engine, get more and more accurate. One of the questions I get is, well, should we use single precision, half precision, double precision? Double precision with accelerators doesn't necessarily mean you'll run faster. You have to look at the use case. I can't go into the details now, but that's what we're planning on doing for the follow-on to this session. And then as we get new data and we try to do these new predictions, that comes in and it continues to be a refinement process.
Yeah, and I think the second part of this, or C of the build out, is we're showing that the data is coming from different places now. The devices actually are getting smarter. You may have just the actuators and things like that. They're pretty embedded. They do a function, but the gateways themselves are able to do more now. They're more intelligent. They have more compute. You can run AI there. You can run machine learning algorithms to make decisions quickly at that level, as opposed to having to ship the data off to a cloud or a data center to make decisions and then losing that real-time ability to make business decisions. It could be from turning off a piece of equipment because it's starting to vibrate too much and it could damage it and it's very expensive, all the way down to it's a pipeline of some sort, and you need to actuate something to shut things off because the pressure's getting too high. The key is it can happen there. It doesn't have to happen, and you can train those models with what we're calling a distributed core. That's an edge compute platform that's purposeful. It's not just hardware and then someone just put some software on it. We've thought about how we're approaching this architecture with the distributed core. It can land closer to the edge. It allows you to then run additional analytics on top of that. It could be GPU, FPGAs, to do rescoring and stuff like that you would traditionally do in a data center or a public cloud.
Go to the next one.
And so,
quick check, we got about 8 minutes.
Okay, so you said distributed core, I used that word, I'll go a little bit quick, but the idea, as I said, it's a purposeful platform. We're taking platforms and we're giving them purpose to run automated provisioning. They have accelerators, self-service, multi-tenant, security, so secure ledger. You hear that called blockchain sometimes. Same concepts, right? We're managing the data, who has access to it, how they get access to it, and what they're doing. Monitoring, software defined. We're using vSAN. We're using NSX. It's got Pulse IoT device manager on there, so we're connecting this downstream so your gateways are now managed through the systems management style. So the hardware that's being managed, and it gives sort of the IT, OT guys vision into what's happening. And then lastly, lifecycle management. The whole stack can be upgraded and maintained in a validated way, right? It's not something that's like, hey, go grab some random firmware and let it fly, see how it goes. No, we're validating these things, and they're sort of blessed, if you will, on how you would maintain and update that. And by the way, a lot of this is built off of VCF. So I don't know if you guys saw the keynote tonight or today, but it was, it's bringing together all these different solutions and making them sort of turnkey to the customer, so that they don't have to focus so much on how it operates, but more, and it's using the things that they're already comfortable with if they're VMware customers, but they can go focus on their workload and they're driving their business. And oh, by the way, they can scale this very easily because we're going to make it easy to bring to the market for the sales folks and for the partners and everybody else.
Yep. Well, so I want to talk about one other aspect. Many cases, if you're in the IT industry or you're working with technology, in many cases you'll have that IT-centric focus on things. And typically the IT groups are focused on the enterprise applications, but in AI and IoT, we start thinking about operations technology. This is, they call it OT. This is where you have the business people focus on the business and the IT people focus on IT. There is a relationship between the two, but the idea is let the people who focused on business intelligence to specialize on that, and let IT do what they're good at on the specialization of that, but still do a partnership. And when we look at this, we have OT looking at covering the details around what we would have at the edge data centers, where we have the Internet of Things, the sensors, the actuators, and here I'm showing a cloud that's tied to the OT group, where we show analytics and data lake. That is how some customers have been doing this. In fact, there's a lot who have done it that way, where OT and IT is the same person, which causes sometimes a conflict or a challenge in trying to focus on the business problem to solve and not have to worry about the underlying infrastructure. But as we go forward, my company, VirtualStream, and other companies are looking at how to actually help the customers focus more on the OT, and that's where we start moving this closer to the cloud provider or fully into the cloud provider area. There will still, I show this as an overlap because there's still going to be dev tests, sandbox evaluations that might be better done on-premise or within the customer's cloud, but then for the mission critical workloads, we want to make sure we have those guarantees, the SLAs, we have the availability, and we have the security that can allow them to take it to production, which is similar to what we're doing with Toshiba. They focus on the IT, we focus, the OT, and we focus on the IT. Okay.
And so building off that, what John was going about at the hybrid IT model, the convergence of that is Pulse IoT. Raise the hands. Anyone know what Pulse is? Anyone heard about Pulse? Not a whole lot of hands, so that's good and bad. But what Pulse is really engineered to do is manage your IoT gateways. The cool thing about it is that we're bringing to bear the manageability, the compliance, the monitoring, zero-touch onboarding for these devices. Security obviously is a huge component of that. The focal point though allows us to take the software solution, which is Pulse, couple that with, if you'll click the next.
Oh, yep, sorry.
So it's bringing together the two different optics from IT OT to say, hey, look, we know there's sort of cultural paradigms there that they don't really necessarily interact that well. Usually it's through exception. OT's like, yeah, I want to do this. IT's like, yeah, you can't do that. Well, then get an exception, you go do it. Through natural sort of progression of merging the hardware and the software, they just do it organically. they don't necessarily have to be in agreement, but they're able to get a voice, and they can drive their standards and maintain that compliance through the shared stack and the shared software. So you click one more, so that brings in the idea of distributed core being the platform that they both share, right? IT can own it, but the OT side of the house can then pull in the gateways, if you click one more. Sorry. The gateways that are operating off of that distributed core, and they're using Pulse to maintain and monitor, and then that brings in, again, the vision of the convergence of them working together, not necessarily having to interact as much as they would typically, but they can use the same applications, and that's an aggregation model for that. And then IoT Edge operations connectivity. This is just a scenario of showing sort of the awareness that IT and OT have, right? They kind of blend at a very narrow spectrum, but we're looking at the different scenarios today of how they operate and the different use cases that we need to solve for. And so the first one is obviously Pulse today uses gateways, it goes directly to a data center. That's their model today. As they grow, they're going to start to support things like a distributed core. So you can run distributed core and connect it out to the public cloud and have a hybrid model for how you move your data and manage your IoT landscape. You still have the standalone model though, where you have manufacturers who still want to run a distributed core and have gateways, but they're not going to connect outside of that, and we understand that, but still, it's the opportunity to support that and grow that. And then lastly, I think the sort of the sort of North Star is that you have this hybrid model where you're giving them something like a micro data center that could be a smart retail space outside of a building, or it could be outside of a park, and you land a distributed core inside of that, but you still have your data centers and you still have the cloud. And you're choosing to move the data how you like to between those different elements, and then you're using Pulse, if you'll click one more, and it can live in multiple places. We're introducing an idea that as they move towards a SaaS model, that you have a master of masters. And so you may have multiple Pulse instances running downstream, and they're managing very large ecosystems, but you can aggregate that back to one and monitor it all and govern it from one space. So that makes that easier as you grow to allow that you can stay in compliance and allow cyber guys to have their purview into the space.
And we see this as a true multi-cloud. My company focuses on mission critical workloads. There are other companies that do that, but there are also other companies who focus on non-mission critical workloads. You'll have to look at your ecosystem of your environment within AI and IoT to determine what makes the most sense for each of those different types of provider benefits. Yep. So I'm doing a quick build down on here, just to kind of give you the overview of the different sections. We talked about the cloud of clouds to make this big analytics cloud. This is actually showcasing where the different stages for AI and IoT would fit in. The edge cloud would have things like the devices, the edge gateways and analytics, although some of the edge gateways may overlap, like with distributed core, closer to the actual cloud or the core data center. We have the data collection and storage of training data. The initial collection may be at the edge, but at some point there is a central repository, a storage cloud. We have the deep learning in that core, we have the classifier engine, we have the prediction, the inference, and then we get the additional unknown IoT data coming in to further learn, make predictions, and also refine the accuracy of the model. And so this kind of shows you where the cloud fits. Pulse IoT I'm showing here on the edge, but with the way that things are going right now, it goes all the way back to the core. If you want to add a point to that, we got about 4 minutes. So
yeah, I think that's a good example. I think the key is that they're all interconnected at some point. They're not living on their own. They all work as an organism, and you have to use them and manage them that way.
Yep. Now, this is what I would consider, there's all kinds of terms you could use, but I think this is the one that I think you'll find the most valuable. What is the vision for the future? Based on what we know from today's technology and where we see things going, based on customers and partners and the industry in general, this is what we see. Look at the hardware layer. There's traditional compute, storage, networking. We've now seen accelerators added for doing the AI, the special math that's required for doing those predictions for the classifiers and the prediction engines. We also have this concept of intelligent gateways and embedded gateways. The intelligent gateways will have the GPUs so you can do edge analytics, but the embedded gateways might be at a building or in a particular other location. This upper layer shows you the system of secure ledger, desktop as a service, accelerators as a service, traditional clouds for storage and compute, but also Containers as a service are very essential for this particular process because many of the customers we're talking to now are using Kubernetes with Docker containers. There are other ones that fit into there as well. We need to have governance across all of this. And the last thing on this one key area is thinking about the system that goes together to create this one big cloud made up of these smaller elements and how they all work together. Last area we'll go through very quickly. I'll do a quick build out.
Sure, so it's
about a minute.
showing sort of that it's, again, thoughtful. These are solutions that we're engineering, we're layering software on top of them to make it easy for the customers to adopt. We're looking at a base configuration, a storage configuration, and analytics configuration, and pulling in third-party products to help them be successful.
Yep. So the one thing we want to leave as the last takeaway is that with Dell Technologies, we're trying to work together in a very solid ecosystem, partner with other vendors like NVIDIA and others that are out there to actually give you a total solution end-to-end, including the financial and professional services that are needed as well. So I'm going to leave this with asking you if you can fill out the survey. We'd love to get that. The vBrownBag team really appreciates it because it helps them determine what are the next sessions that they may want to choose. And if you are interested in doing a vBrownBag talk, I highly encourage you to talk to the people behind the crowd who are making us happen. So what I'm going to leave this with is our contact info. Because we have other sessions coming in, we're going to step off, let other people come on and get ready. And if you have questions, we'll talk to you back there in the vBrownBag.
Thank you very much.
Behind the vBrownBag area. Thank you guys. Thank you.
How you doing?